like to thank all participants of this conference and organizers for the chance to introduce for you our reports in this difficult time for all of us. And the name of my report is Granulation of sorbents of the base of AIM4 and SIV, titanoyl-silicates. So first of all, I would like to introduce you with our center. The name of our center is the Kola Science Center, and this is situated on the Kola Peninsula. It's one of the northern part of our country, and we located near with Finland and Sweden. And as you can see on this slide, the first image is the Hibini Mountains. It's the place where we can find different samples of the interesting minerals. And after that, we, as usual, we work with the natural minerals. You can see one of these examples on these pictures. It's a lenticide, for example, and cookieswomite. So how we work in our center? At first, the group, which includes different scientists from the different science areas, so for example, from geological science, from mineralogical, and from chemistry, for example, we start to find some special and interesting samples of the natural minerals. After that, we try to study their specific properties and to find some interesting examples for the practical area. And after that, in our nanomaterials research center, we try to synthesize one of the more interesting examples, and after that we use it for the different practical applications, for example, for sorbents and catalysts. So as you can see on this slide, in different alkali masses of our region, we have a different number of known titanoyl-silicates. Titanoyl-silicates is one of the interesting materials after the zeolites, which are the very famous molecular sieves and sorbents, and these materials, these titanoyl-silicates, have a very similar crystal structure for zeolites minerals. On this slide, you can see one of the example of these minerals of the titanoyl-silicates is the mineral cookieswomite. These minerals are very interesting for a practical application because they have a crystal structure based on the silicon oxide tetrahedral and titanium oxide octahedral coordination. And these different chains based on the one framework, titanoyl-silicate framework. And as for this mineral, its crystal structure contains in one framework with the special linked cations. For example, in cookieswomite, it can be the zinc oxide. And it's very interesting that this material can be transformed in the new material, which can be consist only the titanium oxide chains and silica oxide chains. And this material can be used at the special nanopuzzle matrix for different radionuclide cations, or the sodium cations, or silver, and for different cations too. Another sample of these of such materials and such minerals is the mineral evonucite. You can see the samples on this slide. This is the cubic minerals like these. This material is very interesting for the radionuclide conservation, especially for cesium and strontium conservation, and it has interesting crystal structure like a zeolite too, with very wide channels for these for the sorption of cesium and strontium cations. These crystals, these minerals can be synthesized in the lab, and as you can see on this slide, the synthetic material have a very similar for natural crystals crystal structure too. This is based on the silicon oxide tetrahedral 2 and titanium oxide in octahedral coordination too. And especially in literature, we can find different information about the synthesis when we can use the special very clean reagents for this reaction for hydrothermal synthesis. But in our lab, we use this salt, titanium salt, which is the long saving product from our regional mining company. And besides, we can use in our synthesis different wastes from the mining companies, and from the metallurgical companies too. For example, the special acids. And what interesting products we can obtain on the base of these materials. First of all, it's a different functional materials. Especially it's recyclable different sorbents and sorbents for cleaning electrolyte from silver and from the plumbum too. And the next area is the photocatalysts and heterocatalysts area. On the base of these materials, we can we can use it in this area for obtaining the special anti-convulsant drugs and medicals, for example. And the next area is the synthesis of 1-methoxy-2-propanol, for example. We can use this material for biocide activity, for materials with biocide activity. And as I have already said, we can use these materials as a sorbent for an immobilization of radionuclide cesium, strontium, and iodine too, if we will use the special modification titanosilicate, which consists the silver cations. And the next practical application is the energy sources. So we can use these materials as the matrices for lithium cations, for example. And in nowadays, we have problem with the granulation of these materials, because if we would like to use it in the practical application, first of all, we should to know how we can obtain it in the granulation form. And as we try and plan to use these materials in different practical applications, the potential binders should include a lot of different conditions for practical applications of these materials. And this can be and should be that the binder should be insoluble in dilute aqueous solutions, wastewater model solution, and alkali solutions, as we will said about the liquid radioactive wastes, and acid solutions, if we will say about the electrolyte solutions of copper nickel production, for example. The second, the binder component should not sorb onto its surface or include elements extracted with the help of a sorbent, especially in the case of using a sorbent for liquid radioactive waste. The binder is, in the case of radioactive chemistry, should be removed from the granules when the spent sorbent is sintered into the strong titanosilicate like ceramic. because the temperature in these processes more higher than 600 degrees. The binder component should be non-toxic and environmentally friendly substance, and the binder should ensure the
Ma'am, you have
maximum.
2 minutes to conclude, please.
Okay. I think that I will end. So in our experiments, we try for these reasons to use the different binders. And first of all, it was the chlorinated rubber, and the result of this granulation you can see on these figures. And on this case, we have used the mini glad fluidized bed unit. And in the second case, we have used the centrifugal granulation for granulation our material without any binder, and we have used only distilled water. And as you can see on this figure, the result of the morphology of our powders were more better, because in this case we can obtain the special spheric granules. And in conclusions, we can say that tenosilicates we obtained in granulation form in each case of these granulations. And it has been established that granules of spherical phase shape and large particle size can be obtained using centrifugal force. And it's very important that this is only the first steps of our experiments, and we try to investigate and develop this work step by step in the future. Thank you for your attention. If you have any question, I would like to discuss it and try to answer on it.
Thank you very much for.
To thank you for the organization of this conference, and to give us the possibility to participation of in this conference also. So our work is in relation of protection of environment protection and recycling waste, entitled optimization of triboelectrostatic separation of PVC fine particles using response surface modeling methodology. So my presentation is divided in 5 points. We start with the problematic of waste recycling, and we talk about experimental device using in separation process. And the third point is the study of parameter effect on separation process, and parameter experimental study, and we finish with conclusion. So the environment and quality of life have become major concerns of our society in recent years. The recovery and the recycling of waste is an important economic activity and real source of energy for many countries. However, in Algeria, especially, this area remains very little exploited. It should be noted that reducing waste in Algeria, waste is sent to the landfill or incinerated. So the waste treatment in Algeria is still far from the standards desired by the other authorities. In addition to the many shortcomings in the collection of domestic and industrial waste, only 5% of 3.5 million tons of waste per year are recycled. Mainly the recovered plastic, while 60% is potentially recyclable. Among the most recyclable are PVC, ABS, PE, PS, and PP. So for better recycling of waste, the recycling stages for treatment of waste, we start with the collection of waste waste, and then analysis of the quality and manual sorting comes before grinding of waste and into granular products to obtain at the final stage the process pure product for separation. Electrostatic separation has established itself as the most reliable alternative. High yields are obtained for granular mixtures for millimeter size using several devices such as tribo-aero-electrostatic separator with vertical electrodes and free fall tribo-electrostatic electric separator and two-stage tribo-aero-electrostatic separator. These devices have the same operating principle, which is to charge the particles in a fluidized bed by a triboelectric effect in order to separate them in area of intense electric field, which is located here. However, current technology only supports the separation of granular material of millimeter size. So in other hand, the process of separating particles of micrometric size are less efficient owing the aerodynamic forces which affect their trajectory. So this figure represents a photography and the overall descriptive diagram of our new separator, which is located here, area of separation process. The two disc metals are powered by a high power supply of opposite sign. And here the injection of air for triboelectric chargement. For better understand the principle of our separator and animation, the design of our separator, the two metal discs are mounted on the same shaft using an insulating slider, after which we have a plexiglass wall separation chamber, and the wall of the face which contains steels are brooms, and the brooms below the chamber there is distribution boxes for injected air here. Injected air for the phenomena of triboelectric phenomena. Also, a collector for the collection of separated particles. So the operating principle of our separator, the two discs are powered by signed opposite signed power supply, which is give here an electric field and with the higher strength, and the separation area of separation is located here between two electrodes. So for the separation process, several forces are contributed for process of separation. These forces are mainly aerodynamic force, electric force, gravitational force, centrifugal force, and dry friction force. The next step is the modelization of our separation process to obtain the optimal value for better separation products. So the optimization was used for the methodology for the response surface modeling was used to optimize our processes. This methodology can be following 4 steps. The first is to choose the factor that may influence the separation process. The second, identification of the range of variation of various factors and effect assessment. And we finish with determination of the optimum operating point. So for our study, we opted to choose 3 factors which are most important for the separation process. These factors are mainly electric field and injection air flow and rotation speed of disks. This figure represents the mass collected as function of electric field. So from these preliminary results, for the choice of interval, we noticed that the recovery increase with the increase of electric field, and we have opted for electric field minimal of 2 kilovolts per centimeter, and electric field maximal electric field of 4 kilovolts per centimeter for the limits of interval of variation of electric field. The same in the same of the disk rotation speed, which the mass collected as function increase with the increasing of rotation speed. That is explained by the fact of the increasing of rotation disk means the increasing of force, centrifugal force, and detachment of the particles collected from the disk. So according to those results, the speeds interval was chosen as followed. Rotation, minimal rotation of 60 RPM and maximal of 100 RPM. Also for failure rate, so we opted to choose the interval of 24 liter per minute and 29 liter per minute to for study of the optimization of separation process. In this slide, we report to all composite experiment given in with the software mod 5. As the table presents the results of the 27 experiments carried out according the 5-centered composite experiment design. So from this plot shown in this figure, it's become obvious that we can see that the electric field and the air flow have a significant influence on the phenomenon of separation. Only these 2 factors should be used to optimize the phenomenon to increase or decrease recovery, as they have a significant effect. And he finds that there is no interaction between the factors for white PVC. So according to mod 5 software, the best electrostatic separation of fine particle corresponds to flowing optimal value of for around 4 kilovolts per centimeter and 100 RPM and around 29 liter per minute for optimal values. In order, as a conclusion, At present, there is several separator based on electrostatic phenomena. However, the difference in separation process seems to be a determining point. The triboelectric separator with fluidized bed proves the high of its yield compared to the other separators. This separator has recycled with success the micronized products. The results obtained in this paper show that the electric field applied to the rotating discs was the most significant factor in the separation process. The separation rates attained 86% to the introduced mass for optimal values, and tribo-charging of granular plastic mixed series in fluidized bed is multifactorial process. Indeed, a study of this phenomenon is essential, such as separator. So thank you for your attention, sir.
Thank you very much, Dr. Yasin, for your presentation.
Hello to everyone. Thank you very much for inviting me to this conference. I know that the situation is really bad, so unfortunately we cannot meet in person. Plus, as I understood, the audience is interdisciplinary. So I would like to ask you to do not hesitate to ask questions during the presentation in case there are some terms that they're not easily understood because I'm in another I'm working in another domain than you. I see there is a question in the chat. No, it's not. Okay, great. So today I'm going to talk about ICT in higher education, teachers' experience during COVID-19 pandemic in France, Greece, and Mexico. So 1 year ago, with a colleague of mine, Eli Orlando Lonzano Gonzalez, we had the idea of creating a project that has to do with COVID and try to investigate teachers' experience during COVID. I'm just trying to, okay, great. So as you know, the COVID-19 disrupted the pace of higher education worldwide. More than 1.5 billion students and youth have been affected, and schools and universities closed because of that. So we were interested to examine two questions with this study. First, teachers' readiness and response, which means their ICT training before COVID, their familiarization with ICT tools, the learning practices and the teaching format before COVID. And secondly, their experience and their presentations, which means their point of view regarding e-learning, the relationship with students, the time spent on e-learning during COVID, and the benefits and the disadvantages of e-learning. I just need to clarify that when I refer to ICT, I refer to information and communication technologies. So the participants, we have 3 countries. We have Mexico, France, and Greece. In total, we have 465 participants, 56% female participation, 43 male participation, and 1% define themselves as other. The age varies a lot. So here I'm just giving the resume of the ages, but more or less we have young students, young teachers in France, and older teachers in Greece, and then Mexico. So we have also teachers coming from public and private sector, especially in France. So the first category of our study examines teachers' readiness and response. Regarding to ICT training before COVID, here are the results of our question. We asked teachers if they had received any ICT training before the COVID, and here we see that actually Mexican teachers have received mostly an ICT training, while teachers from Greece and France they have in their majority not received as much ICT training. So even if we see here that Mexican teachers, they have already had an ICT training experience. In the next slide, we see that Mexican teachers, they are the ones that they are the less comfortable with ICT after the COVID than in the other countries. So while French and Greek teachers look more confident. So next slide. Here we also try to examine the learning practices. When we say learning practices, we refer to the ways, to the tools that they use in order to enhance ICT use. We see that most of the teachers, they used self-education as tool. When we talk about self-education, we refer to for example, going to internet and try to find tutorials or different tools that can help us to teach. This is something that like all the countries agreed it's the most important tool. Then we have colleagues help in France, basically. University tutorials basically in Greece with 64%. And I want to actually tell you that we were quite impressed by the fact that family help was something very important to Mexico with 17%, while in France we had the 0% replies on family help. So yeah, but we will try to explain that later. Now, yeah, we were also interested to know the format of teaching before COVID. It's quite an important parameter in order to examine the ICT familiarization. And we see that actually Mexico is the only country where we have an 80% only distance learning before COVID. So in Mexico, we have different programs of e-learning programs in higher education, while most of the countries, they had an on-site in combination with distance learning format before COVID. Here we have some results from the qualitative data. I forgot to mention that we diffused a questionnaire with closed-ended questions, and we had also two open-ended questions, which gave us some qualitative results. So here we have the ICT experience of French teachers. We see that French teachers are more, they have developed a more positive way of seeing e-learning. So yes, more of them, they were also used to on-site, to remote to on-site teaching. In Greece, teachers see ICT as the only solution as it devalues the courses. And also, we see that for them, the preparation is quite painful. It's something very difficult for them, but most of them, they agree on the fact that ICT saved the courses and helped them to continue the academic year. While in Mexico, the ICT experience was not very good, basically due to problems with internet connection. We see that some of the teachers, one of the teachers says that he had to pay data to some students to send them information. And also that they had to find their own ways to do a self-training. Yeah. So I continue to the second act, which is the experience and the challenges. We wanted to know if teachers spend more or less time to ICT comparing to before COVID. We see that in Greece and Mexico, teachers say that they spend more time to ICT than before. with 70% for Greece and 59% for Mexican teachers, while in France, 44% of teachers, they say that they spend less time. So,
Ma'am, you have 2 minutes to conclude, please.
I'm sorry. Okay, I will try to go, to continue. So regarding attendance, participation, and interaction of students during the courses, we see that all these indicators remain mostly stable, apart from Greece, but we will see it in the conclusions. The most important advantage of e-learning was time management and non-use of transportation, and we think that these two correlate because we save time because we don't use transportation. And the most important disadvantage is the loss of contact with students for all the countries, with 84 and 81% for Greece, 84% for France, 81% for Greece, and 50% for Mexico. The last quantitative indicator show us that in Mexico, teachers believe that ICT had a positive impact in their relationship with students comparing to other countries. So I will quickly pass to the feelings of the teachers. To conclude, like French teachers, they have a negative opinion about the role of e-learning to their relationships with students. In Greece, they think that this is just a way to continue the courses, and they kind of adapted to it. In Mexico, we have 2 points of views. Most of them, they are quite positive with ICT, while some of the teachers, they are quite stressed. Okay, and finally, I'm here for the conclusions. We see that teachers receive the basic training, but which is not enough. All the 3 countries use self-education techniques to enhance their ICT learning. Students' interaction met an important decrease during e-learning in Greece, while attendance and participation met an increase. For the fourth point is that the benefit of the ICT for most of the teachers, as I told you, is time management due to non-use of transportation on a daily basis. The other disadvantage is the absence of readiness of the governments to adopt an e-learning model. And finally, the initial training shows that the highly effectiveness on teachers and students' relations. We see that because in Mexico, Mexican teachers who had received more ICT training comparing to the other 2 countries recognize a positive effect of e-learning, while French and Greek teachers, they appear more pessimistic about it. And I will finish here. Please don't hesitate to ask any questions. I know that we are coming from different fields, but I guess that this is a quite interesting topic for us, because we all live in COVID and we all have to face e-learning. Thank you a lot. I'm ready to receive any questions.
Thank you very much. Thank you very much. One of the interesting